All right, welcome to the Explainer. Today, we're going to decode something pretty amazing, the parabola. Yeah, it's just a simple curve, but believe it or not, it holds this universal code that shapes, well, almost everything, from the perfect arc of a baseball to the way a satellite dish works.
I mean, you might not even notice it, but this shape is everywhere. Seriously, the universe seems kind of obsessed with this simple U shape. You see it in the laws of physics, you see it in financial charts. It's this fundamental pattern that's basically written right into the fabric of reality itself.
And I'm talking about real-world stuff. You see its shape in the path of a basketball as it arcs perfectly towards the hoop, or in the super precise design of a satellite dish that's focusing a signal, and even in these massive, grand structures like our most famous suspension bridges. So you gotta wonder, right? What is the secret code behind this shape? How can one simple curve explain so many different things? Well, that's what we're here to figure out. Let's dive in. Okay, so it all starts with this shape we call the parabola. And it's not just any curve, it's like the OG, the simplest but also the most profound. It's really the visual blueprint for, well, all curvature.
And here's the thing, the parabola isn't just a pretty shape. It's almost like it's a piece of geometric intelligence. It captures the ideas of reflection, focus, and acceleration, all packed into one single elegant curve. It's kind of brilliant.
And look, this is not just some abstract math class concept. I mean, this is the actual language scientists use to describe gravity's pull on an object. It's how light reflects in a telescope. It's even how economists and, yeah, AI programmers figure out how to find the absolute lowest possible cost for something. It's that powerful. So how does it do all this? Well, this physical shape, it has an algebraic blueprint, a code, and that code is the quadratic equation. This is the exact spot where the visual world of geometry smacks right into the symbolic world of algebra.
So here it is, the equation in its standard form. But hey, don't let it scare you. Don't think of it as just a formula you have to memorize. Think of it more like a set of instructions. It's what's called a curved causal law. A fancy way of saying it tells you how a cause, x, leads to a curved effect, y. It is literally the recipe for drawing any parabola you can imagine.
Now, see those letters A, B, and C? You can think of those as the control dials on this equation machine. When you tweak them, you change the parabola's shape and where it sits on the graph. And each one of these dials has a very, very specific job. Okay, so let's start with A. The A value is kind of like the master control. It handles the curve's steepness and its direction. If A is positive, whoosh, it opens upward like a rocket launch. But if A is negative, it gets pulled down, kind of like a falling apple. Simple enough, right?
So what about B and C? Well, the B value, it works together with A to shift the whole thing left or right. It's what decides its line of symmetry. And then you've got C. C is the grounding point. It literally sets the starting height on that vertical axis before anything else happens. It's what physicists would call the initial condition.
All right, so we've got the code. Now let's take a look at the key landmarks that this code creates on the graph. And I'm telling you, these are not just random points. Each one represents a moment of really profound meaning. First up, we have the roots. Sometimes they're called zeros. Basically, they're the spots where the curve actually hits the horizontal axis. But let's get a little poetic here, because they're really existence thresholds. Think about it. It's the point where a thrown ball finally lands on the ground. Or for a business, it's that magic moment where profit goes from negative to positive. Next, we have the vertex. Now this is the big one. It's the very top or bottom of the curve, the apex. And for anyone interested in optimization, this is the single most important point. It's the maximum height a rocket reaches. It's the minimum cost for a business. It is the peak of the arc. It's everything. And what holds this whole beautiful shape together? That would be the axis of symmetry. It's this perfectly straight vertical line that runs right through the vertex, and it slices the parabola into two perfect, identical, mirrored halves. It's like the formal proof of the parabola's elegant, perfect balance. Okay, this is where it gets really cool. What if I told you there's a hidden oracle tucked away inside that equation? A tiny piece of the code that can actually predict the future, well, the future of the parabola solutions anyway, before you even do any of the hard math. Yeah, it's a real thing. It's called the discriminant. All you have to do is calculate this one little value, b squared minus 4ac. And just like that, you can predict the parabola's future. It tells you exactly what kind of contact that curve is going to make with that horizontal line of reality we talked about earlier. It's amazing. Just by looking at whether the discriminant is positive, negative, or zero, we know the outcome. If it's a positive number, bam, our parabola crosses that reality line twice, 2 solutions. If it's exactly zero, it just comes down and kisses the line at a single point, 1 solution. And what if it's negative? Well, then the parabola represents a potential, something that never actually makes contact with our real physical world, no real solutions. Okay, so let's zoom back out for a second. We've got all these pieces now, the A, B, and C dials, the vertex, the roots, that little oracle called the discriminant. Let's see how they all combine to form what is, essentially, the algebra of physical law. And here it is, the whole shebang, the full quadratic formula. And look, it's so much more than just a tool for finding where the curve hits the x-axis. It is a profound statement about symmetry in nature. You see that plus or minus sign right there in the middle? That's not just a math symbol. It perfectly reflects the 2 mirrored halves of the parabola, its duality and balance, captured in an equation. So this whole map, it just ties everything together so perfectly. Every single one of those abstract math concepts from the equation has a powerful, real-world meaning. The parabola itself, that's the shape of gravity and optimization. The roots, those are the thresholds of reality, the state transitions. The vertex is the sweet spot, the optimal value. It's not just a bunch of parts, it's a complete system of thought.
And you know, when you really step back and look at it, the quadratic equation shows us something incredible. It shows us that math isn't just about crunching numbers. It is a deep, rich language for describing the universe itself. It takes the complex patterns and laws of nature and encodes them into these simple, elegant symbols, which it really leaves us with one big question, doesn't it? If this one single equation can reveal so much about how the world works, just imagine what other secrets are still hiding in the language of math.